Hello, sir. I'm doing a reassessment for Chapter 2, Attempt 2. And here the question states that there is a spacecraft goes towards Mars and it is carrying a heavy payload of 1200 kg. And this payload has to be moved along the hallway of the spacecraft and has to make a 90-degree turn without touching the floor, walls, or the ceiling. And there is a program of a fire blast of compressed air in the payload, which lasts up to 1 second to help it move in desired direction. And the force of the compressed air is about 20 newtons. And the question asks us how long does it take to complete an entire move? So here the system is the load and the spacecraft, and the surrounding is everything else. So the given information is the payload, the load, which is 1200 kg, the blast of compressed air which is up to 1 second, the blast force, which is 20 seconds. And in the question, they have given us 3 points: the starting point, the first section, which is at 030, and the last section, which is 4,3,0. So with that plot, I just plugged it in. So it starts at 0,0,0, and it heads up to 0,3,0. Then it makes a right turn at 90-degree angle, and it heads up this way at 4,3,0. So after this, I found that from the given information, we know that y is 3, we know the x is 4, and we're missing this right here. So to find z, I just used the simple Pythagorean theorem, which is nothing but z square is equal to x square plus y square, and we know z is nothing but the square root of x square plus y square. So 4 square plus 3 square, so 16 plus 9, 25. Square root of 25 is nothing but 5. And so the 5 is the distance between the beginning and right here. So that's the displacement. So once we do that, the question asks us to how long does it take? So we need to find the time. So to find the time, I use this formula right here, the displacement formula, which is nothing but d is equal to v naught t plus 1/2 at squared. So we know what d is, which we just found, and we know v naught to be initial velocity, and we know time, t is time, and 1/2, and there is acceleration, which we need to find, and t squared. So to find the acceleration, I use this formula right here, force into mass time acceleration. So solving for acceleration, I get F over m. And we know the force from the question to be 20 newtons. And we know the mass to be 1200 kgs. Right here, I changed it to kgs per meter second square. So it's easier to work with. So it's more linear to the problem. So 1 Newton is nothing but kg or meters or second square over 1 Newton. So cancel out, and by dividing them, I get a value of 0.0167 meters over second square. So now, after I found this, the acceleration, so I have all the missing parts in the question. So we can go ahead and solve for time. So we found the displacement to be 5 meters, and we know the initial velocity from the question to be 0. So 0 times t, so it's 0, so that's nothing, plus 1/2. We know that we just found the acceleration to be 0.0167 meters per second square, and that's time square. So solving for time square, we have this half right here. So by moving it this side, I have to flip it. So once I flip it, the 2 goes up. So 2 times 5 is 10. So 10 divided by 0.0167 meters per second square, and the meters cancel out. And once I divide it and take the square root, I end up with 24 seconds. So the time taken to complete the entire move is 24 seconds. Thank you.